Good afternoon, ladies and gentlemen and viewers. Normally I say with a smile on my face, "Hi, this is me on the settee," but today I want to be very serious. We hear day by day of people, but primarily celebrities, who've left us, and invariably they've left us because cancer has got a hold and has taken them away. We ask ourselves, why are so many people dying of cancer-related diseases? The answer is very simple. It can be put down directly to the aerosols and the particulates from burning hydrocarbons. Now, we can find cures in inverted commas, but we can put cancer into recession or remission, and some of them, the remission lasts forever and we call it a cure. But basically we should go back to basics and say, why are so many people getting cancer-related diseases? And if we go back that far, we could say, well, it must be because the carcinogens are in our food chain. So if we could find a way of removing the carcinogens out of our food chain and out of the air that we breathe, then by default we would have cured cancer, but it would probably take 100 to 200 years. So the purpose of this talk today is to lay the foundations as to how we can remove the hydrocarbon aerosols and particulates from the global atmosphere. I'm going to explain to you, by waving these various bits of paper about, how it is possible to run the world on water without using any hydrocarbons. Now that is a sweeping statement to go viral on YouTube. So first of all, I'd like you to look closely where my finger is pointing, and this is a still shot of what we Google call London's blow-up pavements. In very simple terms, there's about 115,000 cable pits throughout the London locality, and occasionally some of them blow up. Now, the media are saying that it's to do with natural gas being ignited by an electrical spark. But what it is an electrical short circuit creating a plasma that is then igniting any moisture that's in the cable pit, giving you an explosion of hydrogen oxidized by ozone. In other words, it's like having a massive lightning discharge in a cable pit just underneath your feet. But the interesting thing is that if this lightning discharge or plasma ignited explosion could be harnessed, then we could well be on our way to running the world on water. Now, I can go back to the early 2000s when I approached Imperial College and asked them if they would do some research for me on the plasma electrolysis of water, only to be told that not only could I not have any laboratory space, but the chap in charge of providing laboratory space was told that he should have nothing whatsoever to do with my project. The reason for this is that back in the late 60s, the British, and I use that in inverted commas, had found a way to mass produce hydrogen peroxide. And I had actually, or inadvertently, come across something that was covered by a D notice. But since then, if you look where my finger is now pointing, this is just a snippet, the tip of the iceberg, of the number of thumbnails of video clips on the whole paraphernalia of the plasma electrolysis of water. So you can see that there's a lot of information out there. And why are we not using the plasma electrolysis of water? Because nobody has found a way of putting a high current and a high voltage together in a viable power electronic form. I'm going to now explain to you my latest patent application where I found a way of doing this. So I shall now put this down and pick up these few pieces of paper. This is exactly as it went to the patent office, and it basically shows, and I'm going to show you this, which is a profile of nothing more than possibly a petrol engine or a Lister D petrol engine. These were two-stroke engines, and they were made of cast iron and literally made by the tens of thousands. And even as I speak, they're still being churned out under license in India. They're stationary engines, and they make a small amount of electricity, probably just about a kilowatt from 1.5 horsepower. But the reason that I'm showing this to you is that it is cast iron, and so consequently I can heat it up without it distorting too much. Now, if we now look, you will see there is your piston, and all the pistons are at the bottom, and they're driving the conventional crank. Now, you're seeing just one section, but imagine them being doubled up, and through the rotating axle you have a series of motors which can also be configured as generators. The idea is that the conventional magneto sits on the crank and dictates the firing of the electric current to make the plasma. So consequently we have steam that is coming through these pipes here, and the steam is continuously present. So all the time the piston is at bottom dead center, you have triggered the center coil of a high voltage, high current relay, which has closed the positive line from your high current feed. This has put probably 100 amps at about 110 volts through the steam. The steam has then exploded in a similar fashion to London's blow-up pavements. So if you look at those X, each one of those is a blowing up pavement. Now, because we're not trying to synchronize to make a reciprocating engine, the explosion takes place when every piston is at top dead center. As the piston recedes, whether it is pushed by the explosion is academic because it's already been driven, the plasma current is still flowing. The plasma current only switches off when all the pistons are at the bottom or bottom dead center. Now the steam will quench what has ever happened inside here and cool it down. What we're now doing is snatching a few of the loose oxygen atoms from the steam. This is making the vapor very hot but also hydrogen rich. You will see that by these coloured squiggles that we tried to get rid of as much of the gas as possible through the large open apertures. This gas is now, and I'm going to put this down, forcing its way through boiler tubes. I have used a cross-section of a steam engine boiler as a handy aide-memoire. So imagine you have your pistons here, and the steam and the hot gases are passing through your tubes. By default they're heating the water, which of course is going to make your steam. But as the hot gases enter, which is now the smoke box, which we will now call the receiver or the condensing box, they are hydrogen rich, and so consequently they can go back into the steam line, and this time they will explode and burn at a higher temperature. As the temperature keeps climbing, then consequently you're taking more oxygen atoms out of your hydrogen rich vapor. When we reach the stage where the steam is too great, we can then vent it through the safety valve into a receiver, which would be illustrated here. And as you can see from the abstract one on figure 1 on the initial patent application, there are some eyes and some arrows. Now these eyes and arrows represent not steam as we know it, but a mixture of hydrogen and ozone, which is where we came in. Hydrogen and ozone, if blended correctly, makes high-test peroxide or hydrogen peroxide. I am not suggesting in this talk that I'm making high-test peroxide, but I am suggesting that I'm making a weaker version of hydrogen peroxide. But nevertheless, this version will still interact with potassium permanganate or a silver catalyst to produce superheated high temperature steam, which can be used downstream to generate electricity through a turbine. So what has this all said to you? It has basically said that for a given amount of electrical power into my system, which I have called the reciprocating, do bear with me, the reciprocating volcanic, because of the eruption on the top of the piston, compounder, because we are compounding the vapors to make hydrogen, weak hydrogen peroxide. If the figures work out correctly, what you're looking at is the first stage of being able to produce the global energy needs from water, which is vindicated by London's blow-up pavements and all the experiments that other people across the planet have carried out on plasma electrolysis of water. On that bombshell, if I may, I will now leave you to consider what you will now do with this information that I've laid at your doorstep. Thank you once again for listening and looking and viewing, and please tell everybody else to go to Richard Vere Compton on YouTube and look at his latest patent application, which is, of course, the reciprocating volcanic compounder. I thank you once again. May God bless you. Bye.